So we're going to take a look at rule 5, and rule 5 says when different side chains or substituents are present in the same molecule, the substituents are arranged, that is the side chains are arranged in alphabetical order to redefine their position. So let us get to understand what this rule is talking about. When we have different side chains in a given molecule, they will be arranged alphabetically to redefine their position. Now, this is a case where where we are going to have different side chains that are not of the same species. But in rule 4, we saw that we may have the same side chains. And when we have the same side chain in a given molecule, we are going to give such name as di, tri, tetra to such side chain as it is being attached to the hydrocarbon chain. So in this case, we are having different side chains. So let us get to see how to name that compound. The first example is CH3, CH2, CH, CH2, CH3, CH2, up there, CH2, CH2, CH3. So, how do we get to name this compound? To name the compound, we need to identify our parent chain first. And the parent chain, a student may choose to go this way. That is our longest continuous chain. And if you look at that, we have 7 carbon atoms. So it means that the name of that compound is going to end with heptane as the parent chain. It's going to end with heptane as the parent chain, since there are 7 carbon atoms in that hydrocarbon. Now, I want to make it clear that if a student chooses to go the other way by taking his or her parent chain by another route, it doesn't make your answer any wrong. You're also going to get the same thing, but always remember that there is a rule that says if we have 2 or more numbering schemes that are of the same length with the same number of side chains, you should simply pick the straight chain. Don't forget, a student may choose to go this way. A student may choose to go this way. If you choose to take your parent chain like this, you're still going to get the same thing. You're not wrong. You're not wrong. But only recall that a rule says when we have a possibility of 2 or more routes that will give us the same number of carbon atoms for the parent chain, then simply go with the straight chain. If the straight chain is going to give you 5 carbon atoms, for example, and you choose to take your own parent chain to be curved or L-shaped or U-shaped, simply go with the parent chain. That is what the rule is saying. So, I just want to make it clear that if this is student A and this is student B who choose to go the other way by taking his parent chain in form of an L shape, it doesn't make student B wrong. He or she is also going to get the same answer as student A. But what we're saying is a rule is already on ground which says in such cases as this, simply go with the straight chain just to make things easy for you. So let us stick with the rule and also stick with student A who chooses to go straight. Now, having seen that, we have taken our parent chain as the longest continuous chain. So having seen that, let us go ahead to number the parent chain, because we've identified our parent chain, and identifying our parent chain automatically we have also identified our side chains. So let us proceed now to number the parent chain. Don't forget, the numbering of parent chain affects the side chain. How? The numbering of parent chain says that when you're numbering your parent chain, you should number your parent chain from the side that will give the side chains a very low number. That is to say, you are to attach very low number to the side chains. You have to attach a very low number to the side chains. So we must follow the route or the path that will attach low number to the side chains. Now, if we choose to go from the left hand side, this is going to be carbon 1, this will be carbon 2, this will be carbon 3, this will be carbon 4, carbon 5, carbon 6, and this is carbon 7. But if we choose to come from the right hand side, okay, let us finish with the left hand side first, so that it doesn't get us confused. Now, if we choose to come from the left hand side, we have two side chains. One is methyl and the other is ethyl. This is ethyl and this is methyl. Don't forget, ethyl, this is ethyl because it is C2H5. And we know from our knowledge in alkanes that C2H6 is ethane. And when alkanes loses one hydrogen atom, they become alkyls. So when ethane loses one hydrogen atom to become C2H5, automatically it's no longer going to become ethane. It's no longer going to become ethane, but ethyl. It's no longer going to become ethane, but what? Ethyl. Ethyl. So what we have here is ethyl. So having understood that vividly, let us now continue with what we ought to know. So this is ethyl, while the side chain above is methyl. So it means that ethyl is attached to carbon 3. It falls under carbon 3. While methyl falls under carbon 4. So if we are to name this compound, the rule says that they must be arranged alphabetically. E comes before M in the alphabet, in the English alphabet. Since E comes before M in the English alphabet, it implies that the name of that compound is going to be 3-ethyl, 3-ethyl, because ethyl is attached to carbon 3. That is from the left hand side now. This is going to be 3-ethyl, 4-methyl heptane. Don't forget, numbers are separated from numbers with a comma, but numbers are separated from letters with a hyphen. Don't forget that, dear students. Always remember these rules. Now, if we are to start our numbering from the left-hand side, this is actually what we are going to get as the name of this hydrocarbon chain. But if we are to number from the right-hand side, if a student begins his or her numbering from the right-hand side, automatically this will become carbon 1, this will be carbon 2, this will be 3, this will become 4, this will become 5, this is 6, and last of all, this is 7. So it means that if we are to number from the right-hand side, our methyl will fall under carbon 4, and our ethyl will fall under carbon 5. So automatically, numbering from the right hand side, the name of that compound will be 5-ethyl 4-methyl heptane. That is what it's going to be. Now the question is, which of these names is correct according to our rules? We should remember the rule which says that to number our parent chain, the numbering should be done in such a way that the side chains get the low number, the lowest possible number. So 3-ethyl 4-methyl in comparison to 5-ethyl 4-methyl, which do we think has given a possible low number to the side chains? Of course, you guessed right. 3-ethyl 4-methyl should be the right answer. So automatically, this is wrong. It is wrong because going from the right hand side will give ethyl a higher number, though methyl remains the same. Whether from the right or from the left, methyl still remains at carbon 4 at the 4th position. But ethyl changes. Coming from the left, it gives ethyl 3 as its number. It falls under carbon 3. But coming from the right, ethyl falls under carbon 5. So automatically, it means we must follow from the left-hand side. So this is how numbering of parent chain is done. So ethyl must be given the lowest possible number. Even ethyl is bigger than methyl as a side chain. It is bigger than methyl. So for that reason, it should be given a low number. So this is the first example. Let us take a look at the next example.